Okay, guys, today we're going to start the process of solving rational expressions. But before we do that, we need to look at some situations where we may have some extraneous solutions, some solutions that when we plug them back in won't end up working. Okay, so let's remember a couple things about fractions. And one being that if we have a 0 in a numerator, that's considered okay. All right, sometimes we write O over K is all right. We can have that 0 up top. What is not okay is to have that 0 on the bottom. You cannot divide by 0. You cannot have your 0 in the denominator. So that would end up being a n over 0, no. Okay? All right, so an extraneous solution is any solution that we get that when we plug back in gives us a 0 in the denominator. Okay, because we cannot have 0 in the denominator. So any solution we get, we need to make sure we check by plugging it in to make sure that it works. Okay? When we have an extraneous solution, we're just going to go ahead and write no solution. Okay, so for example, if we look at number 1, we have this x minus 5 over x minus 7, and we're plugging in x equals 7. Okay, so if I plug that in, 7 minus 5 over 7 minus 7, that would equal 7 minus 5 is 2, 7 minus 7 would be 0, and we'd have no solutions. That's not okay. So we go ahead and say no solutions, because that would be extraneous. Here is another example. -2, plug it in, -2 plus 6 equals 4. -2 plus 2 equals 0. Again, extraneous. Okay, not okay. All right, so let's start looking at some problems here and going back and seeing if we can find some solutions, okay? So here we're going to go ahead and see what's canceled. We're adding. Remember, you can only cancel from a rational when you're adding. It has to be that same fraction. Okay, so here where we have x minus 1 and x minus 1, those can be canceled. That x plus 5 here is going to have to stay where it is. Okay, on the right side, we do have an x plus 5 on the top and x plus 5 on the bottom, so those would cancel. And we'd be left with only numbers in our numerator. We'd have 3x and the x plus 5 that I circled above, plus 4 times x minus 1. So the denominators would completely cancel. Okay, let's look at number 4. Look what can be canceled. This time we have an equation, so we have factors on both sides. On the left side, we have this x minus 6 can be canceled, this x minus 6, this x plus 3, this x plus 3, this x plus 3, and this x plus 3, and x plus minus 6, x minus 6. So all of a sudden, instead of having rationals equal to each other, we now just have 6 times x plus 3 plus 2x times x minus 6 equals 17x. So instead of having this complex rational equation with two fractions, polynomials on top and bottom, and then another fraction on the right side of the equation with polynomials on top and bottom, we have a much more simple quadratic equation that we could factor out and solve, okay? So it's very handy, instead of having those rationals, if we can cancel, we should. It makes it simpler, right? So if we look at this, and we want to simplify this expression, we're adding two rationals. And if we were to add two rationals, remember the thing to do would be to multiply by the other, right? So we're going to multiply this one on the left times x plus 7. And the one on the right times x minus 3. What am I doing there? Okay, and I need to do top and bottom because I'm multiplying times 1, x plus 7, x minus 3. And now if you look, we have a common denominator on both sides of the equation. X minus 3, x plus 7 on both sides. All terms have that, okay? So what we can actually do is by multiplying both sides by x plus 7 and x minus 3, we can clear the fraction, okay? And what happens is they end up canceling. But what you need to know, what the main trick that you need to know, is that if you have denominators that are the same all the way across, and we multiply by that, they end up canceling. So you can basically, or what you can do, is just cancel all of the denominators if they're the same for every term on both sides of the equation. And what we end up with then is x plus 7 times 4 plus 5x times x minus 3 equals 6x plus 7. From there, we can go ahead and distribute x times 4, 4x, 7 times 4, 28, plus 5x times x, 5x squared, and 5x times negative 3 minus 15x. Okay, and that will equal 6x plus 7. Okay, you could then take that, and we can combine like terms. We have our 5x squared, negative 15x plus 4x would be minus 11x. And then we have our plus 28. And then that equals the 6x plus 7. Okay, if we wanted to solve that, then we could set those equal to 0 and solve. Okay, and we'll actually do that down below. All right, so if I'm looking here at example number 6, I'm going to go ahead and go through the process of solving. So I'm going to multiply this problem on the left times 2 and 2. The term on the right of the left side of the equation, I'm going to times x minus 3 and x minus 3. Okay. If I were to factor on the right, that GCF of 2, I'd have 2 times x minus 3. So that means we do now have the same denominator on both the left and the right. Once I have the same denominator on the left and right, I can multiply times that number, and it ends up canceling it. Okay, so we end up with 2x plus, I'm going to go ahead and distribute, x times x is x squared, x times negative 3 minus 3x equals 6x. Okay, so now we have combined like terms on the left side, x squared minus x, 1x equals 6x. I'm going to subtract 6x from both sides. Get x squared minus 7x equals 0. Okay, it is a quadratic, so we wanted to set it equal to 0. Now I'm going to factor the x squared minus 7x. I have a GCF of x, so x times x minus 7. And I can set those equal to 0. X equals 0, and x minus 7 equals 0, which means x equals 7. I then want to make sure that those will not give me a 0 in my denominator, because I don't want any extraneous solutions. If I plugged in 0 minus 3, that would be negative 3. That would be okay. 2 times 0 would be 0, minus 6 would be negative 6. So I plugged in the 0 here. That'd be okay. So both all right. 7 minus 3 would be 4. That's okay. 2 times 7 would be 14, minus 6 would be 8. So that's okay. So both these solutions are good solutions. X equals 0, x equals 7. Let's move on to example 7. Okay, same thing. I'm going to multiply by the other denominator. X minus 1, x minus 1, x minus 6, and x minus 6. Okay. If we factor x squared minus 7x plus 6, two numbers that multiply to equal positive 6, and sum negative 7, be x minus 6, x minus 1. Okay, so I just factored that, so I'm done with that. I now have the common denominator everywhere, x minus 6, x minus 1, so I can go ahead and clear my denominators. Okay, and then multiply the numerators. X times 3x, 3x squared. Negative 6 times 3x minus 18x. 2x times x plus 2x squared. 2x times negative 1 minus 2x equals numerator from the other side. 5x squared minus 15x plus 20. Okay, let's go ahead and combine like terms on the left. 2x squared, or 3x squared plus 2x squared is 5x squared. Negative 18x minus 2x minus 20x equals 5x squared minus 15x plus 20. Okay, I'm going to go ahead and subtract 5x from both sides because that clears my quadratic. That'd be nice. I'd much rather deal with the linear. Okay, so now I have negative 20x equals negative 15x plus 20. I'm going to add 15x to both sides, get my variable on the left, my constant on the right. So I'm adding 15x to both sides. I get negative 5x equals 20. Divide both sides by negative 5. X equals negative 4. If I plug negative 4 in to my original numerators, negative 4 minus 1 would be negative 5. That's okay. Negative 4 minus 6 would be negative 10. That's okay. And then negative 4 minus 6, negative 4 minus 1, no zeros anywhere. Okay, so I'm all good with negative 4. That is my solution. Okay, guys, that's 1 through 7. Those are the examples and the practice work. Okay, you guys should go ahead and complete problems on the back, the practice work, and let us know if you have any questions. Thank you.